This is one additional piece, kind of an enrichment for section 2.7 day 2, and you'll see a couple of these problems. These are optional problems, but you can we're going to be trying to take this one and solving it for x, so isolating it for x. This is just a good exercise in algebraic manipulation, just using your algebra rules to try to get x by itself. So a lot of crazy fractions going on here. What we're going to do is just try to break it down one piece at a time. And so the farthest inward we can go is this one right here. Now if you add fractions together, remember that you have to have a common denominator. So one thing we're going to have to do with this whole equation right now is we're just going to have to change the denominator, this one right here, to be able to put them together. So 1 plus 1 over x, if we want to get a common denominator, that's going to have to be x over x and then plus 1 over x. Now that those have a common denominator, we can put them together, leaving the denominator the same and making the numerator x plus 1. So the next step looks like this. So we got 1 over and then x plus 1 over x. All right, now that we have that, what we're going to do is try to make more sense of this complex fraction here. So whenever you divide by a fraction, you are multiplying by the reciprocal. So that means I could do 1 divided by this, or I could do 1 times the reciprocal of that one. So I'm going to rewrite that again. 1 plus 1 times x over x plus 1. All right, so now anything times 1 is just itself, so I really could rewrite this as 1 plus x over x plus 1. So we haven't done everything yet, but we at least have gotten to the point where we have a little bit less complicated. Now let's work on getting rid of this one here, kind of putting those two things together. So the way that we could do that is kind of the way we've been solving equations all along in this chapter, and that is by multiplying by the least common denominator on everything. There's only one denominator here, and it's x plus 1, so I'm just going to multiply everything by x plus 1 and then see where this takes us. So if we do that on the left-hand side with that y, it just has to be x plus 1 times y. And then on the other side, you distribute 1 times x plus 1 as x plus 1. And then with this last term here, x plus 1 cancels with x plus 1, so we just have plus x. So that's looking better again already. Now that we have this, let's try to get just the x's on one side, get the y's on one side. I think the best way to do that is to distribute this y to both of those pieces. So we'll have yx plus y. And then we have this equal to, if we combine some like terms up here, 2x plus 1. All right, now let's get the x's and the y's kind of separated from each other. We're trying to solve for x here, so we just want the x pieces to be on one side. So let's switch the 2x and the y around. So what I mean by that is I'm going to subtract the 2x over here, and I'm going to subtract the y over here. So yx minus 2x equals then 1 minus y. The reason I did that is to get all the x stuff over here, and now we can actually factor that x out, leaving y minus 2 in the parentheses there. And now we just have a single x for this problem, and we have 1 minus y over here. Maybe you see it now is that the last step, we can get x by itself by dividing by this y minus 2. So we have 1 minus y over y minus 2. And that's the last step. That gets x by itself. This is kind of just an exercise in algebra and using your algebraic skills. But hopefully that makes sense up to this last point. You do have to do this little trick with the factoring, but then it should work out as you see.